Have you ever wondered how fast an object falls due to gravity? If you have, you're not alone. And today, we're going to explore this question together. So let's first take a step back and understand what gravity really is. Gravity, in simple terms, is the force that pulls everything towards the center of the Earth. It's the reason we don't float off into space, and it's also the reason objects fall when you drop them. But here's the question we're interested in. How fast does an object actually fall due to this force? We're going to investigate this by performing a simple experiment, dropping an object from a tall building and timing its descent. It's a straightforward and effective way to measure the speed at which an object falls due to gravity. In this experiment, we'll find out just how fast an object can fall. To conduct this experiment, we need a few things. First and foremost, we need an object to drop. This object should be dense enough to minimize air resistance but also safe to drop from a significant height. A small dense rubber ball fits the bill perfectly. It's dense, it's safe, and it's easy to track as it descends. Next, we need a stopwatch. Precision is key in this experiment, and the stopwatch will allow us to measure the exact time it takes for our object to reach the ground. You might think you can just count 1 Mississippi, 2 Mississippi, but trust me, a stopwatch is much more accurate. Then, we need a tall building. The taller, the better, as this allows the object more time to accelerate due to gravity. However, we need to ensure that the building is not so tall that our object reaches terminal velocity. A building around 10 stories high should be perfect for our needs. Now let's talk about safety precautions. We're dropping an object from a height, so we need to make sure the area below is clear. We wouldn't want our little rubber ball to cause any unexpected surprises. A designated and controlled drop zone is essential. Also, we should inform any nearby people about the experiment to ensure their safety and cooperation. The setup process is quite straightforward. We position ourselves at the top of the building with our object and stopwatch. We secure the drop zone below, ensuring there are no unsuspecting passers-by. We then position the object at the edge of the building, ready to drop it and start the stopwatch simultaneously. Remember, the key to this experiment is precision. The moment the object leaves your hand, start the stopwatch. The moment it hits the ground, stop the stopwatch. If you manage to nail this timing, you're halfway to getting accurate results. With everything set up, we're ready to start the experiment. With our setup ready, it's time to conduct the experiment. Let's start by going over the steps. We're going to launch an object from a tall building and time how long it takes to reach the ground. Now remember, safety is paramount. We've ensured there's no one below and the area is clear. We also have a team member on the ground at a safe distance, ready to observe the landing. First things first, we need to start the stopwatch. Timing is everything in this experiment. The stopwatch starts the moment the object leaves our hands. We're not throwing or pushing the object, but simply letting it drop. We're allowing gravity to do all the work here. As the object begins its descent, it might seem like it's falling slowly at first, but don't be fooled. It's accelerating all the time due to the pull of gravity. And that's what we're here to explore. Now, as you can imagine, stopping the stopwatch at the exact moment the object hits the ground is crucial. It's all about precision. This is where our ground observer comes in. With a clear view, they'll signal the moment of impact, helping us stop the stopwatch accurately. One thing to note is that our experiment is not immune to errors. Factors like wind resistance can slightly alter the object's speed, but don't worry. Our aim here is not to provide a perfect measurement, but to demonstrate the principle of gravity and how it influences falling objects. And just like that, our object has completed its journey from the top of the building to the ground. We stopped the stopwatch. The time it took for the object to fall is now locked in, ready for us to analyze. And there you have it, the object has hit the ground. Now let's see what we can learn from this. Now that we've conducted the experiment, it's time to calculate and understand the results. To calculate the speed of the object's fall, we're going to use the recorded time and the height of the building. Remember, when an object is dropped from a height, it accelerates due to gravity. This acceleration is approximately 9.8 meters per second squared on Earth. So let's start with the time it took for the object to hit the ground. We've measured this with our stopwatch. Now we'll use the formula for the distance traveled by an object under the acceleration of gravity, which is half times the gravitational acceleration times the square of the time it took to fall. Now let's plug in our values. We'll use the gravity constant of 9.8 meters per second squared and the time we recorded. When we do the math, we get the distance the object has fallen, which should be close to the height of the building. If the number we've calculated is significantly different from the actual height of the building, then that could be due to several factors. Our timing might have been off, or air resistance could have slowed the object's descent. Now let's calculate the speed at which the object hit the ground. We can do this using the formula for the final velocity of an object under the acceleration of gravity, which is the gravitational acceleration times the time it took to fall. Again, we plug in our values and voila, we have the speed at which the object hit the ground. This experiment and our calculations show us that the speed of a falling object increases the longer it falls. That's due to gravity pulling it down. The speed at which the object hit the ground is its fastest speed, and we call this terminal velocity. But remember, in a vacuum where there's no air resistance, all objects would fall at the same speed no matter their mass. This principle was famously demonstrated by Galileo dropping two balls of different masses from the Leaning Tower of Pisa. Our experiment also shows us that gravity is a constant force. It's constantly accelerating objects downwards at approximately 9.8 meters per second squared. This is an essential principle in physics and is fundamental to our understanding of how the world works. So, understanding the speed of a falling object isn't just about knowing how fast something falls, it's about understanding the forces that govern our world, like gravity. It's about understanding the principles that guide everything from an apple falling from a tree to the orbits of planets around the sun. And that's how we can calculate the speed of an object falling due to gravity. So, we've conducted our experiment and calculated our results, but what does it all mean? Let's take a moment to reflect on our journey of scientific discovery. We began with a simple question about gravity, an invisible force that's so integral to our lives yet often overlooked. We set up an experiment to investigate this force, using nothing more complex than a tall building and an object to drop from it. This setup was designed to be simple and accessible, to show that the pursuit of science isn't limited to high-tech labs and experts in white coats. We launched our object from a great height and timed its descent. From this, we calculated the speed of the object as it fell, and in doing so, we were able to gain a greater understanding of how gravity works. Our results showed us that an object in a vacuum will accelerate towards the Earth at a rate of approximately 9.8 meters per second squared, regardless of its mass. This experiment is a powerful testament to the beauty and simplicity of science. It's a hands-on demonstration of a fundamental law of nature, and a shining example of the scientific method in action. But beyond that, it also serves as a reminder of our place in the universe. We are bound to the Earth by the force of gravity, a force that governs not only the fall of a dropped object, but the orbits of planets and the very structure of the universe itself. But our journey doesn't end here. This experiment is just the tip of the iceberg. I encourage you all to continue experimenting, continue questioning, continue learning. The world of science is vast and endlessly fascinating, and you don't need a lab coat to explore it. We hope you've enjoyed this experiment and have learned something new about gravity. Until next time, keep exploring the wonders of science.